I'm super excited that you're in class today. Our focus for today's class is chain rule. And some textbooks call it function of a function. And how do we know when to apply this particular rule? This rule is used when we are faced with a problem of having to compute a function that is kept inside another function or more than one function at the same time. What do I mean by this? Let us take, for instance, if we have a function y is equal to x plus 5 raised to the power of n. Looking at this function, you realize that we have one function which is x plus 5, which is kept into another function which is raised to the power of n. Let us call that function u, and it is raised to the power of n. Therefore, u equals x plus 5. So I can restate this first equation to be y equals u raised to the power of n. So with this, you can see that when we have a problem where we have to compute more than one function at the same time, then the best method to use is the chain rule. Let us take, for instance, a pregnant woman. Take the pregnant woman to be a function and the baby inside her to be another function. You'll see that the baby, which is a function, is kept into another function, which is the mother. So when we have something like that, then we know that the method to use is called the chain rule. In computing the chain rule, we have two major methods. And I'm going to walk you through the two methods. The first one is the normal long method. The first method is illustrated beneath. Let us take an example. If we have y equals 2x plus 1 raised to the power of 3, and we are asked to find dy over the x. Now, the first thing you have to do is to assume a particular function for what is in the bracket. Invariably, what I meant is, let us say u is equal to 2x plus 1. And if u equals 2x plus 1, therefore, y will be equal to u raised to the power of 3. I'm sure you agree with me. Yeah. Let's call this equation, equation 1, equation 2, and equation 3. So we have to differentiate equation 2 and 3 with respect to their variables. From equation 2 will be du dx, because here the dependent variable is u while independent variable is x. So du dx is equal to 2. And I'm sure by now you know the reason why I said du dx equals 2. Okay, now from equation, this is equation 2, then from equation 3, we have the two variables y and u. So we have dy du is equal to 3u raised to the power 3 minus 1, which is 3u raised to the power of 2. And having done this, we will now go over to the formula for chain rule, which is dy dx is equal to du dx times dy du. Don't forget this formula, it is very, very important. Dy dx equals du dx times dy du. And how do we go about this? If we cancel this out, you realize that dy dx is also equal to dy dx, so as to cancel the effect of du. Okay, now going to what we have, we already know that dy du is equal to 3u raised to the power of 2. So dy dx here can be equal to dy dx is equal to 3u raised to the power 2 times 2, where 2 is, from this we know that 2 is equal to du dx. Alright, so if we compute this, we'll have that dy dx is equal to 6u raised to the power of 2. And from our initial assumption, we said let u be equal to 2x plus 1, that is what is in the bracket. So, and that is seen from equation 2. If we substitute that value inside what we have here, we would see that dy dx is equal to 6 into 2x plus 1 raised to the power 2. Let me confirm. Yeah, 2x plus 1 raised to the power of 2. And that is seen as our final answer. Okay, this is the final answer over here. Now I promised that I am going to show you two methods to solve it. This is the first method. Let us go over to the second method. That is method 2. Method 2, we still have the same problem. Y equals 2x plus 1 raised to the power of 3. This is our problem. And we are asked to find dy dx. Follow these rules very well. The first thing is to bring down the power, which is 3. Okay? Multiply by the differential of what is in the bracket. That is, differentiate what is in the bracket here. And if I differentiate what is in the bracket, of course, I will have 2. So, we have 2. Then return what is in the bracket. 2x plus 1 and reduce the power by 1. If you reduce the power by 1, you have 3 minus 1. So if you compute this, you have 6 into 2x plus 1 raised to the power of 2. Very simple, easy, and short. If you confirm this and compare, you realize that we have the same answer. 6 times 2x plus 1 raised to the power of 2 and 6 times 2x plus 1 raised to the power of 2. And that is it. Let me ask you a question. If you're given an examination question and you're asked to compute the dy dx of this particular function, which method are you going to use? I'll leave that question for you to answer. But me, of course, I'm going to choose the second method because it is easy and short. This is where we end it on this concept of the chain rule. In our next class, we're going to solve more examples on chain rule. Till we meet again, bye for now.